Hello. So good evening, everyone. Welcome to the week two of this tutorial session on this course, Digital Signal Processing and its application. So we will see some of the concepts and the questions based on the concept which were taught in the second week of this course. And this video is also recorded. So we are recording this video and it will be uploaded on YouTube. So if anyone misses the lecture now, they can watch on YouTube as well. The recording link will be shared on the NPTEL platform. So today we will first start with the discrete time LTI system, which is taught in this lecture series in this week. So we'll start with discrete time LTI system. So let's start the lecture series now. Let's suppose this is our LTI system. LTI system should be linear and time invariant. So if an input Xn is given, then the LTI system will produce the output, that is the transformation of Xn. Okay. So first we will see like both the properties. What is the linear property and what is the time invariance property. So for linear system, what happens? Let's suppose the input x1 passed to the linear system gives the output y1n, and if x2n gives the input y2n, then when alpha x1 plus beta x2 is passed to a linear system, what will be the output? The output will be alpha y1 plus beta y2. Okay, so this is the linearity property. Now second is time invariance property. Like a system is time invariant if the shift in the input signal cause the same shift in the output signal. This means, like, if input signal is shifted by n naught unit, then output signal will also shifted by n naught unit. So let's take example. First I will write time invariant. So when the input xn is given to a system, then output is yn. But now if there is a shift in input by n naught unit, means n minus n naught, and it is given to time invariant system, then what will be the output? Output will be also n minus n naught. Okay, so let's take one example. A simple example we will take to test whether yn is equal to 2 of xn plus 3. Is it a linear comma time invariant? Question. So how we will check? We will check with the properties we have studied for linear and studied for the time invariant. So for linear system, like x1n plus x2n should produce the output y1n plus y2n. Okay, so for x1n, what will be the output here? 2 of x1n plus 3. This is our y1n. For x2n, the output will be again 2x2n plus 3. This is our y2n. Now, when you give x1n plus x2n as input, then what will be yn will be? Yn will be 2 into input is this. So input we are giving now x1n plus x2n. So 2 into x1n plus x2n plus 3. So this will be 2x1n plus 2x2n plus 3. So Now this term, is this equal to the addition of is not equal to y1n plus y2n, because this is 2 of x1n plus 3 plus 2 of x2n plus 3. So this 3 is one extra term. So this is non-linear. Understood? If you have any doubt, you can ask. Now we will check whether it is time invariant or not. So yn is given as in the question 2xn plus 3. Now when the input is x of n minus n naught, then output, what will be the output? Y of n minus n naught is equal to x of, like we are just putting this n value to n minus n naught plus 3. Since the output remains the same after the shift, the system is time invariant. Okay, so this is time invariant. So these two were the basic properties we had to study it. Now we will see one convolution problem, because there are lots of convolution question might be in the assignment. So so we were at the first, we were studying linear time invariant system. So whenever xn is given input to linear time invariant system, so the output yn will be transformation of xn. And so this is our hn. Now if xn is equal to del n, that is the unit impulse function, then our yn is equal to hn. That is the system response, that is also known as the impulse response. Okay, so xn can be written as summation of these all we have studied in the lecture, xk del of n minus k, where k is equal to minus infinite to plus infinite. So this is just the shifting property of impulse response. A signal can be produced as the combination of weighted and shifted impulses. Okay. So basically we can also uh, write yn is equal to, in this case, xn convolution of hn. So this can be written as, the convolution equation is x of k into h of n minus k, and k is from minus infinite to plus infinite. Okay. So this is the equation for convolution. So any signal which is passed through a linear time invariant system, then the output will be convolution of its input and the system. And this is the equation for convolution. So now we will solve the convolution question in the discrete domain. So let's solve one example. With that, we will try to know more in details. So given input signal xn is equal to a to the power of n multiplied with un. Here the value of a is less than 1 and greater than 0. And h of n is equal to un. Okay. So find xn convolution with h of n. So first we will draw the sketch. So what is this means? An into un. The first thing from un we can derive that for all negative values of n, signal will be 0. Because what is our un? Un is unit impulse function. So value will be 1 when n is equal to 0 to infinite. So un is equal to 1 for n is greater than or equal to 0 and 0 for n is less than 0. Okay. So this is the definition of unit impulse function. A few people joining now. Okay. So this is the definition of unit impulse function. Now we have to find the convolution of xn and hn. So xn is an into un. So first of all, with un, what we can derive that for all negative value of n, xn will be 0. So now for n is equal to 0, what will be the value of xn? X0 is equal to a to the power of 0 into 1 because u of 0 is 1. So you write here u of 0. So that is 1 into 1. So this value will be 1. Now when you increase n for x of 1, that is equal to a to the power of 1 u of 1. So that is equal to a into 1. So a value of a is between 0 to 1. So somewhere let's suppose this. Okay. Now when you increase it will become a squared, a cube. So and value of a is less than 1. So again squaring will also reduce, and it will directly converges like this. So this is our x of n. Okay. This I was just explaining how to sketch the curve. So I will erase this part. And this is our un, and here hn is equal to un is given in this question. So this is also h of n. Now we have to find xn convolution of hn. So what is the equation what we wrote here? The convolution equation, this one. Okay. So we will write yn is equal to xn convolution with h of n. So this can be given as summation x of k h of n minus k, and k is equal to minus infinite to plus infinite. Okay. So now we have to do this convolution. Let's do it in graphical way. So first step is represent xn and hn graphically. Okay. Now the second step, what we can do? Change the axis from x to k. So now our this is k and this is our xk. So xk will be same what we have found earlier. Okay, like this. And our h of minus k. Why? Because here it is n minus k. So first we will do h of minus k. So hk was, hn was given as this. So h of minus k will be, it will rotate from the 0. Sorry. This is 1 and 2. Okay. So if this is our hn, so what will be h of minus n? It will be the mirror image with respect to the y-axis. So this is our h of minus k. Okay. Now we have to shift it because our equation is xk into h of n minus k and summation of all. So the next step is shifting. This is the graphical way to find the convolution. Now we will do shifting of h of n minus k. Because see what we have to do in convolution, we have to find xk multiplied with h of n minus k and do the summation. Okay. So we have already found xk. We have found h minus k. Now we will find h of n minus k. So if it is n minus k, this means it is h of minus k plus n. So in this case, the signal will shift to n unit. So here, so this is our h of n minus k. And what will be the value of h of n minus k? This will be equal to 1 up to when? Minus infinite to n. Okay. So, and it will be 0 when for this part. Okay. So, we can write here for n minus k less than equal to 0. Okay. This will be 1, and for n is greater than k, this will be 0. And how we have done this? Let's suppose n is equal to 2. Let's take in this case n is 2, 1 and 2. So up to what value h of n minus k will be greater? It will be up to 2. It will be 1. So, and for what value it will be 0? For n is greater than k. Okay. So now we will multiply this and we will do the summation. So our yn, this is equal to x of k into h of n minus k. So this will be like this. This was our x of k. Okay. And at the same time, this was our so the black color is h of n minus k and the red color is x of k. So when we do the summation, what we will get? Yn is equal to, this is simply multiplication of xk into h of n minus k. Up to what value? Up to value of n, because after n it is becoming 0, h of n minus k. So this summation will be up to k is equal to 0 to n. Okay. So now k is equal to 0 to n. And what is xk given? A of n. So it will be a of a to the power of n. And h of n minus k is 1 between 0 to n. H of n minus k is 1. So this summation of an, what is the value? 1 minus a to the power of n plus 1 divided by 1 minus a. Okay. If n is greater than equal to 0. So this is our answer. So this way we can do the graphical approach for the convolution, but we will also see we'll see some more questions based on this week. Now we have already studied about linear shift invariant, that is linear time invariant also. For discrete domain, we are using the term linear shift invariant. Okay, because in discrete domain there is no time; it is shift. Time is sampled. That's why we are using the term shift. So it is given h of n is equal to alpha to the power of mod n, where n is z and alpha is between 0 to 1. Okay. So now we have to find like which of the following options are true. This system is given to be linear shift invariant. Okay. And what will be the output of the system? Let's suppose linear shift invariant is the system, and if we give input xn, so what will be the output yn? Yn is equal to xn convolution of h of n. Okay, so y of n is the convolution is equal to x of n convolution h of n. Now the option A asks the output of the system for input xn is equal to e to the power of j omega n. So our input is given. So we have to find the convolution of these two. So we know the convolution equation of convolution. Here we have written y yn is equal to xk h of n minus k summation. So same we will write the same equation, and value of k is equal to minus infinite to plus infinite. So, and we can also write in alternate way x of n minus k into h of k. Both can be possible. Okay. So y of n is equal to summation of x of n minus k. What we will write? E to the power of j omega n minus k. This is our x of n minus k into h of k. What is the value of h? Alpha to the power of n. So alpha to the power of mod k, and k is equal to minus infinite to plus infinite. So y of n is equal to, see this n is independent of k, so it will come out e to the power of minus j omega k alpha to the power of k. So again, so yn, see the yn will have the same phase. This beside the phase of the system, so yn will have the same phase, and there will be some different magnitude we can find using this. So for this, option A is the correct answer. Now we'll see for option B. If the input of the system is odd, then output at n is equal to 0 is. Now option B. The convolution equation first we will write. The output at 0 they are asking. So n is equal to 0 will substitute x of minus k, h of k. So y of 0 is equal to k is equal to minus infinite to minus 1. What will be the value? X of minus k, and hk is our alpha to the power of mod k. So this will be alpha to the power of minus k for k is negative, and alpha to the power of k if k is positive. So this is just the definition of mod function. So now what we will do, for negative k it will be alpha to the power of minus k plus x of 0, and for k is equal to 0, that will be 1, alpha to the power of 0, so it will into 1 plus 1 to infinite x of minus k alpha to the power of k. Okay. Now, if the input is odd, therefore these two summation will cancel each other. Okay. Now the only term remaining is this remaining term. Therefore, output y0 is equal to x0. Why? Because here you see, if xn is odd function, so odd function will always pass through the center. So odd function x of 0 will be 0 only. So the answer is x of 0, so option B is also correct. Now, for option D, we can substitute the value y is equal to 2, and we will find, so option D will also correct. You can just substitute the value in this summation. Y of n is equal to, here it is given, xn is un, unit input function. So yn is equal to summation of u of k into h of n minus k, and k is equal to minus infinite to infinite. Here we have to find y of 2. Y of 2 is equal to, this uk is 1, so 1 into h of, and this value should be, k should be greater than 0 only. For negative value it will be 0. So k is 0 to infinite, uk will be 1, and h of n minus k, what will be the value? Let it write as it is. So this is equal to, and h of n is alpha to the power of mod k. So alpha to the power of mod of n minus k. Okay. Now we have to put n is equal to 2. So y of 2 is equal to, for k is equal to 0, what will be the value? Alpha to the power of 2. For k is equal to 1, it will be alpha to the power of 1. If k is equal to 2, it will be alpha to the power of 0, plus k is equal to 3, to alpha to the power of minus 1, plus so on. So this will be the answer. Okay. So we can write alpha square plus alpha 1 plus 1, and this term is the AP series. So here we can write a by 1 minus, what is the a plus ar plus ar square. If such series is there, what is the sum? A by 1 minus r. Okay. So here this will become alpha by 1 minus alpha. Okay. So what is the correct answer? When you solve it, option D is the correct answer for this question. Coming to the next question, the output of the LTI system is this. For omega 1 not equal to omega 2, what are the possible input to the system? So, first they are saying output is given as rate of sine 2 omega 1 plus omega 2 into n cos of omega n minus 2 omega 2 into n. Okay, for omega 1 is not equal to omega 2. What are the possible inputs to the system? So we can write the output as 4 into 2 the sine 2 omega 1 plus omega 2 into n cos of omega 1 minus 2 omega 2 into n. Okay. Just a minute. Why this view? Okay. So now when you simplify this, we can write this as 4 into, it is the term of 2 sine into cos. So it will be sine A plus B. So that will be 2 omega 1 plus omega 1. So this will be 3 omega 1 minus omega 2 into n plus sine of omega 1 minus 3 omega 2 into n. Okay? So just give me a minute. So this means our output is linear combination of two sinusoidal function and the angular frequency is this. So since it is an LTI system, the input would have been also a linear combination of sinusoid with the same angular frequency. Thus the like what are the option which have the same frequencies 3 omega 1 minus omega 2 and omega 1 minus 3 omega 2. So we can check. Option B is correct. Option D is correct. 3 omega 1 minus omega 2. Omega 1 minus 3 omega 2. So only option D is the correct option. Okay. So we'll move on to the next question. Which of the following functions are analytic over the real for the entire real values? So for analytic function, the function is analytic if first we'll write the definition. A function fz is said to be analytic in a region of the plane if fz has a derivative at each and every point in that. And if fz is a single valued at that point, so in that case, first we'll write the definition. A function fz is said to be analytic in region of the complex plane if f of z has a derivative at each point of the complex plane. So here we'll find the derivative. So the derivative of this is 6z plus 2. So it is the derivative exists at all points for e to the power of z squared. Again, the derivative exists for sine z also. The derivative exists for mod z. Like this is a mod z function. So at z is equal to 0, like the derivative of derivative of mod z, this is minus 1, and at z is equal to 0, there is a discontinuity. Okay, it is a complete shift. So that's why option A, B, C is correct and option D is not correct. Now coming to the next question. Consider the following system Yn with input xn defined as Yn is equal to x of n squared whole square. Now we have to find whether the system is time invariant, linear or what. So clearly the system is non-linear because you can see this square term is there. For time invariance, y of y of like n minus let's take delayed input x2n, that is given as x of n minus k. Okay, so y of 2n, this is given as x of, we have to give the value of n, substitute the value of n as n minus k. It will become n like n minus k squared to the whole square. Now, is this equal, like this is not equal to x of n square minus k whole square. So this system is time varying also. So option C is correct. It is time varying and it is non-linear. For Yn to be a linear time invariant system with input xn, which of the following is true? So xn is equal to e to the power of j omega n is an eigenfunction of this, because when we give e to the power of j omega n as the input, then uh, the phase remains the same if it is not changed by the system. The system is time invariant, so xn will be the eigenfunction. Okay, like we can write also y of n is equal to summation of hk x of n minus k. So this is our equation of convolution. So this we can write as summation of hk e to the power of j omega n minus k. So e to the power of j omega n will come outside h of k e to the power of minus j omega k. Okay. So here we can see it is just the multiplication. Output is just the multiplication of xn. So it is an eigenfunction. Similarly, option B is also correct. You can verify it. Now coming to the next question. Which of the following statements are true regarding the convolution of the sequence x1n and x2n? So x1n is given as 1, 2, 3, 4, and 4, 3, 2, 1. This is our x2n. Okay. This is our x1n and this is our x2n. Now for convolution, we have seen the graphical approach earlier. First what we will do? We will do x of k and then reverse x2 of minus k. So it will become, so convolution is equal to summation x of 1 k into x of 2 n minus k. So 1, 2, 3, 4, and this is our x of 1k and this is our 4, 3, 2, 1. So now we will find the overlapping area. So these two are overlapping, okay? For y of 0, for n is equal to 0, these two are overlapping. So this value is 4 into 1. For y is equal to 1, now this will shift by 1 unit. Okay, so now it will be 4 into 2 plus 3 into 1. So it will be 11. For y is equal to 2, so for y is equal to 1, what will be the value? Let's see. 1, 2, 3, 4. and now 0, 1, 2, 3. So this will shift, so it will become 4, 3, 2, and 1. So these two and these two for n is equal to 1. Similarly, for n is equal to 2, it will become how much? 3 into 4, because this will shift 2 units, plus 2 into 3, plus 1 into 2. So this will become 12 plus 6, 18 plus 20. So 4, 11, 20, any option is there? So in this question, it's asking the maximum and minimum value. Similarly, we will find for y is equal to 3, it will become 16 into 30. 16 plus 9, 25 plus 4, 29 plus 1, 30. Y is equal to 4. Again, it will become 4 into 3, 12. 3 into 6, 18. 2 into 1, 1, 20. Y is equal to 5. It will become y is equal to 5. It will shift by 5 unit. So only the part is 2 into 4 and 1 into 3. So 8 plus 3, 11. Y is equal to 6. It will become again 4 into 1, 4. So what is the maximum value? 30. Minimum value 4. So the correct answer is maximum value is 30 and the minimum value is 4. So actually y of n is equal to x1n convolution x2n. So this is equal to 4, 11, 20, 30, 11, no, 30, 20, and then again it's 20 and then 11 and then 4. So this is the convolution output for this sequence. The next question is, let xn shown below be decomposed in terms of unit steps function. So we have to decompose xn into unit step function. Okay. So the first starting unit is at -1. So we can write u of n plus 1. So what is u of n plus 1? This is our u of n. U of n plus 1 will be this. So this is our u of n plus 1. Okay. Now at the second unit, the value is 4. So we will write 3 into u of n. So now what will be 3 into u of n? Let's draw it clearly with the same color. 3 into u of n. What will be the value? This value will be 3 and all value will be 3. So okay, these two we got. Now at 1 it is 2. So now the addition of this 3 plus 1 is, this is 1, this is 3. 4. So how much we have to subtract? -2. So again we will do -2 u of n plus 1. So it will be somewhere like this. -2, -2, like this so on. So now we can directly write xn is equal to, with this analogy, we can continue it forward. Xn is equal to u of n plus 1 plus 3 of u of n. 3 plus 1, it is 4. Now at u of n minus 1, Sorry, this is minus 1. It is minus 2. Minus 2 u of n minus 1. Now again we have to do minus 1. Minus of u of n minus 2. Again minus 1. Now it is constant. So this is the sum. So now the coefficient of u of n is 3. So option B is correct. Coefficient of u of n minus 3 is minus 1. So this option is also correct. And coefficient of n plus 1 is minus 1. So this is wrong. And this is also wrong. So which one is correct? Option B and option C is the correct answer for this question. Okay. And the students who have joined late, for them, this video is also recorded. Now, the next question. Let x1n, this is our x1n, shown below to be the input to an LTI system and y1n be the corresponding output. So there is a LTI system which gives this output. Okay. Now the output y2n for the input sequence x2n will be. So for the same LTI system, what will be the output when x2n is given? Okay. So what will be the value of x2n here? X2n can be written as in terms of x1n, 2 of x1n plus n plus 1 minus 2 of x1n. Let's see what is this? 2 of x1 n plus 1. First we'll write x1n. So this value is 0. This is 1. Okay. Now 2 of x1 n plus 1. So this is equal to, it is n plus 1. So it will start 1 unit before, so it will become here 2, 2, 2, 0, 0, 0, and this will be 0. Now, the next term we have done is minus of 2 of x1 n. So, minus of 2 of x1 n will be, this will be 0, this will be minus 2, this will be minus 2, and this will be minus 2. Now, when you add this and this, when you do addition, what we will get? First, we have done n plus 1, n plus 1 shifted leftwards, and then this. When we add this, this will become 2, this will become 0, 0, and this will become minus 2. So actually, it's not getting that sum. See, there is some problem in this input sequence because for getting This x2n from x1n is little quite complex. Or this value, I think this value is 1 in this question, then it can be solved. For all value is 1, then this will be also -2, and this all will get cancelled. So let's little change the question. Let's make it 1 for the all the negative values. So now x2n can be written as 2 of x1n plus 1 minus 2 of x1n. Okay, and it's a LTI system. So our output will be also linear and time invariant. So y2n will be 2 of y1n plus 1 minus 2 of y1n. So this is our y of 1 n, and when you multiply with 2, it will become 2 of y1n. What will be the value? 0. This is 1, so 2. This is 8. This is 14. This is 9, I guess. No, this is 10. So 20, 60. So when we sum it, n plus 1, so it will shift and minus y of n. So it will start with the value. We'll just write this value will become 0 to 6. So this is 3 and this is 1. So 3 into 2, 6. So this will be 2, 6, 12, 18, 9 into 2, 14. And then this is 4, so 8. We'll write y of n plus 1 will be 0, 2, 6. And this is our 0th index. 12, 18, 14, 8, comma 0. Okay. Minus 0, 0. This is our 0th index here. This is the 0th index. And then 2, 6, 12, 18, 48. So now when you do the minus, we will get 0, 2, 6 minus 2, 4. And then again, so this is our 0th index. 2, 6 minus 2, 4, 12 minus 6, 6, 18 minus 12, 6, and then 14 minus 18 minus 4, and then 8 minus 14 minus 6, then 0 minus 8 minus 8. So we can write directly as 2 comma 4, 6, 6 minus 4 minus 6 minus 8. So any option is there? So option B is the correct option for it. So today we will end up the lecture here only. So this video is also recorded and will be uploaded on YouTube. If you have any doubt, you can ask. And if you see the video later on YouTube, there also in the comment section, you can ask the doubt. So thank you everyone for attending today's lecture.